Okay, so in the previous lecture, we learned a new thing. We learned how to use if statements. And when do we use if? When we know that we have to do some kind of repetitive calculation. And if we can arrange the logical structure of the example of the question into a form such that if a certain condition is true, then you are asking MATLAB to carry out a certain set of operations. But if that is not true or something else is true, then it would carry out a different set of operations. So as long as you can tell the story of the question in the form of this kind of conditional statements, you can use if. And if is going to be very useful uh, for writing different types, the scripts and codes for different types of problems as well. Hang on for a moment. I just received an email that a student did not receive the link for the class today. So let me give him the link. Okay, so we covered if in the previous class. Today we are going to look at a different kind of logical structure. It is the for statement. And in the lecture after the midterm, we are going to possibly look at a third type as well, while. But for now, today, let's focus on for. So the way this is structured is very similar to if logically, but you typically tend to use this for structure when you are repeating the same calculation a number of times. And this is different than repeating the same calculation for the if statement, where you did a number of calculations, but the mathematical operations were different for different conditions, right? So if condition one is true, you had set one of mathematical operations. If another condition is true, you had a different set of mathematical operations. On the other hand, when I say that for is good with repetitive calculations, you have the same set of mathematical operations, but you have to do it a large number of times. And you are not really left with any kind of conditional statement as such, like the way we had in the examples that we did for the if statement. So here they're very similar, but they have some very important differences as well. And the differences I think could be clearer as we do some examples. So let's first look at this very simple example, and let's write the code for this. And if you guys have MATLAB open, just type up. So we are writing a script file. So the first three lines are clear all, close all, and CLC. Now let's try out this very first example that I have over here. So I'm introducing a new variable called x. So x is 1. And then I'm going into the basic code structure of the for statement. So for a new variable I equals 1 to say 10, then another new variable y would be x plus I. Okay, and then end. So this is the basic code structure of a for statement. It has to start with the for command or the for function, and then it has to end with the end. And whatever mathematical operation you want to carry out, it's going to be inside that loop. And you are just able to use one set of mathematical operations, unlike multiple set of mathematical operations that you could use on the if structure. Now, we're going to come to this one in a moment. This I is actually called an index variable, which controls how many times this mathematical operation is going to be computed. But let's see what we get from here. So let's think logically of this example first. We introduced x to be 1, and that x is going to be used in this calculation on the line 8. But this line 8 also has I. So for each run of the loop, I is going to be updated based on whatever value of I is stored over here. So in the first run, I is 1. So when I say I is 1 to 10, basically we are generating this set of numbers for the I, right? So in the first run, I is 1. So that 1 is going to be added to whatever the value of x is, and the loop ends. Now in the second loop, it would again go back over here, the control, and now I is 2. The first run is done. In the second one, I is 2. And then in the calculation, that new updated value of I is the one that is going to be used. So let's save this code and try to get the output. So save as, and now if I run this, if you can run it on your computer, see you get a number of values for y. So what's going on? So what is actually happening is this. So in each run of the loop, as the control in MATLAB goes through this loop, initially I is 1 and x is 1. So 1 plus 1 is 2. So that is the output from that particular run of the loop. So this part. Now as it goes back again, and it is going to go back again until it is done with this range of I. So that is going to control how many times MATLAB would carry out this operation. So initially I is 1, done, y is 2. Then it again goes back. Now in the second run, I is 2. So if I is 2, x is still 1. So this is 1 plus 2, 3. And like this. So in the last run, so if you think about the entire range for I, the maximum value is 10, right? So during that run, the value of y should be x plus I. So 1 plus 10, 11. And that's the final value of y that you get. Make sense? So again, a recap. So this is called the index variable. It controls how many times this set of mathematical operations, which is inside the loop, is going to be run. And it would keep on running until it covers this entire range of I. And there are some exceptions which we are going to look at the end of the lecture today, but this is the overall rule. So you control the operation through this index variable. Okay, so let's try something else. Let's try I is equal to 5, 1 to 5, and let's try and now I am suppressing the output in each run by placing this semicolon over here. But to get the final output, which is the output in the last run, let's add another line. To get the output from the last run of the loop, answer is equal to y. So let's take a moment and think what I just did over here. So as we run this code, MATLAB is going to first store 1 for x. Then it is going to come to this for loop and carry out this set of operations. It carries out all the runs, and finally, it has some y stored from the last run. And we want that output for y from the last run. So I have suppressed all the intermediate outputs, and whatever the last y was is being assigned to this new variable called answer. So that's the overall logic. Let's save this. And now, can anyone tell me what should be this number?
11.
So in the last run, x is still 1 and I is 5. So 5 times 2, 10 plus 1, 11. So you're right, 11. So hopefully, if everything is right, we should get an output of 11 for answer. So let's run this, and answer is indeed 11. So in this way, you can also extract the last output from the run and use it for some other calculation or to just show that answer. Any question until now? Okay. So over here, if you look at the PDF, I have tried to explain all the things that I just discussed. So this I, as I said, is the index variable. It has other names as well. Sometimes it's called a loop variable or an iterator or a dummy variable, but I like the name index variable that basically controls how many times this mathematical operation is going to be carried out. Okay, so we know that if we use this kind of syntax for I, the range of I that is being created. So the default increment is 1, but it might not be the thing that you need in a particular example. You might need a different kind of increment. So you can add something else over here. For example, I can modify this code to 1 to 2 till 50. So basically now I is going to be incremented from 1 with a step jump of 2. So if I write this over here, this is the set of I that's going to go into the calculation. Now, these are, of course, very simple examples, but this is a way to check your main code by taking copy pasting lines from here, from the main code, and just running it over here to figure out whether you're actually inputting the correct information into your code. Okay, so can anyone tell me what should be the what should be the answer if I run the code now?
$99.
And can you explain why is that?
What did you say?
Can you explain why should it be 99?
Because the last I value would be 49, which is taken times 2 plus 1, because that's
1.
x.
Correct, good. So you need to make sure that whatever the last number is, which in this case incidentally is not 50 because of the way the step increment was inputted over here. So the last number is 49. So it is quite easy to see because I have tried it out on the command window, but sometimes you won't try out every line on the command window, but you need to make sure that whatever is going in would make sense in the context of the problem. So if I run this, the answer is indeed 99. Okay, so this is what I have explained on this PDF. So you have a starting value for the index variable, a spacing value, which is the increment, and the end value, which is the final value. Okay, let's try out a few more examples. So let's try this first one out. So what is the difference here? In the example that we just ran, we had an external variable x that was going into the calculation. In some examples, you might not need an external variable x. So whatever the index variable is would basically determine what you carry out over here. So suppose if I take x out, and if I do something like this, 1 divided by, let's take the example on the lecture, I plus 1. And if I still keep the semicolon, that would suppress the output from each intermediate run. Let's skip this final form and let's save this. So at the last step, as we saw, the value of I is 49. So this is 1 divided by 49 plus 1, so 1 over 50. And what is 1 over 50? It's 0.02. So that should be the answer. So let's check if that is indeed the answer. And that is the answer. So whatever you write in this core part of the for loop is depending on the kind of problem you are trying to solve. You might need an external variable, like the way we did the first couple of examples with an x, or you might be just the value of the index variable might be sufficient to run that mathematical operation, whatever you are being asked to do for that example. So when you use for loop, and for that matter, whenever you use any kind of syntax or any kind of algorithm for your MATLAB codes, you first need to think about what is the algorithm, what is the reasoning, and what is the storyline that you want to include into the code. And once that is clear to you, the way I might solve a problem might be very different to how you would. But that story should be clear to you, like what kind of operation you are trying to perform. Okay, let's look at a few more examples. But before that, another quick note, and I think we did this in the last lecture as well. We have learned how to develop functions on MATLAB. So when we learn this kind of new commands like if, or for. These are nothing like functions, and these are inbuilt functions. So this shows how useful functions are. And over here in this page, I say that you can have nested for loops as well. And we are going to take a look at an example for that as well. So a nested for loop is something like you have a big for loop, and inside the core part where as of now we are just including the mathematical operations, you can include another smaller for loop. So let's see if we can frame an example on that. So this is the example that I have here. So let's try and understand what we did here. Again, we are writing a script file, so clear all. Okay, so let's type out what we have over here. So for I equals 1 to 5, and this is the bigger for loop. And what we are going to include inside that loop is usually the mathematical operations from the previous examples, but over here, we are trying to learn what is a nested for loop. So there would be another for loop inside. For j equals say 1 to 2. I'm slightly deviating from what I have here, but let's introduce another second index variable. Whenever you write a for loop, there has to be a new index variable. So this j is the new index variable, and there should be another end because you always need to close any loop that you might start. Now, this is the outer boundary of the bigger loop. This is the boundary of the smaller loop. But eventually, you need to come to some kind of mathematical operation that you want to pursue. So that goes into this loop. So what this code is doing is something like this. So y ij is I plus j. And let's suppress the output from each intermediate step. And let's again do something like this. Answer is equal to y to get the final output. Now what's going on here? So let's think about logically what are the different values of i's and j's as MATLAB goes through controlling this set of operations. So what is the value of I in the first run here? The value of I in the first run is 1, right? So with that value of I, it goes into this smaller loop. It goes into the smaller loop, and now it encounters another index variable. And in the first run of that smaller loop, the index variable's value is 1 as well. So with those two values, I is 1 and j is 1, it now comes to the core part of the code where we are trying to introduce a new variable y, where y is in the form of an array where I is now 1, j is now 1, because those are the values that have been carried from that first run. And then this number, that placeholder number is 1 plus 1, 2. So that is the very first run. But once that run is done, once it encounters this end, it does not really go back again to the very first line. It would again go back to the smaller for loops first line. And now the j value is 2, but the I value is still 1 from the run along the bigger loop. So now I is 1, j is 2, and so y1, 2 is 1 plus 2, 3. So let's run this and see if it makes sense to us. So let's save this. And let's run this. So this is the output. So we have basically developed an array. And let's try and understand if it makes sense. So as I said, in the first run, I was 1 and j is 1 in the first run of the smaller loop. So y11, which is this first element of the y array, the element is 1 plus 1, 2. So makes sense. Now in the second run of the smaller loop, j was 2, but I is still 1 because that first run is still happening over the bigger loop. But the second subrun of the smaller loop, j is 2 and I is 1. So this placeholder, which is 1, 2, or the first row, second column is 1 plus 2, 3, right? And this goes on once this loop is done. So this loop would be done when j reaches 2. Now the control again goes back to the first line. Now in the second run of the bigger loop, I is 2. So that 2 then carries over to the smaller loop, and then again it does the iteration of j is 1 and j is 2. And that's how it stores all the different values. So now I'm going to change this code a little, and before I run, I would ask you guys to figure out what the output elements are going to be. So suppose if I change this, I is yij is I plus 2 times j, and j is running from say 3 to 5 instead of 1 to 5. And I save this. So can anyone tell me what should be the first element in y?
5.
And can you explain why that is?
Because j would be 1, so j times 2 is 2 plus I, which is 3.
Okay, correct. So in the first one, I was 3, and then it just took up the value of j. Can you tell me what would be the value of, say, y2 comma 3?
Wouldn't that be like 8?
I didn't hear you. Can you repeat again?
Wouldn't that be 8?
8. Can you explain why?
Because I will be 2 and J will be 3, so 2 times 3 will be 6, and 6 plus 2 is 8.
You are not right. You are right in terms of your logic of the calculation, but can j really be 3 in this code?
In that case, no, I cannot.
So suppose if I run this, so if I run this, and then if I type y2 3, we get an error because j cannot be 3. So your logic is right, the way you try to calculate this particular step, but you also need to keep in mind what are what is the range for I and what is the range for j. Right?
Mm-hmm.
Okay, thanks. So any question on this one? So it might take you a while to figure out which particular run is going on. So there is a run along the bigger for loop, and there is a sub run along the smaller loop. And for each big run, all the sub runs should be done by MATLAB, and then it would go to the next big run, and then again all the sub runs for that second big run. Make sense? So this is how, whenever I ask you later on, and maybe in the homeworks, definitely in the test, to set up arrays like this is the way you do it, where the array elements are controlled by this mathematical operation, and the place holder for that element is controlled by this, which is again controlled by what you set up as your index variables in the big loop and then in the sub loop. Okay? Any questions? Okay, so try out a few more examples like this, and you can play around with this core mathematical operations to figure out if you can predict what the output is going to be like. Okay, so I hope we now have a general understanding of what for loop does. Again, it can carry out the same mathematical operation a number of times, and that's how it is different than if, where it can carry out multiple mathematical operations corresponding to different conditions. So the way for loop has been developed, it is particularly useful for this kind of sums where you have an algebraic expression which can be computed using a series sum like this, where each term is in the same algebraic form, but something is changing. So here, if I write exponential x in the series form, It is x to the power of 0 over 0 factorial plus x to the power of 1 over 1 factorial. So in general, we can think of it as a sum, which is like this. So it's a sum of a number of terms where the generic form is x to the power of I over I factorial. And as long as we can change the value of I and sum all those different terms up, we would get the overall sum, which is exponential x. So this is tailor-made for the logic of for loop, where the index variable is being changed in each run. And over here, this I can be the index variable, which can be changed in each run. And we can figure out the terms from each of those runs and then sum them up. So that's the overall idea. There is just one term changing in this algebraic expression. In for loop, we know that we can change the index variable. Let's use that to figure out what is the sum of all these terms. So with that overall logic, let's try to write the code for this. Okay, so again, let's write a script file. So clear all, close all, CLC. And now the floor is open to you guys. Just try and think about the logic of the problem and suggest the first lines, how we should approach this problem. What should be the first line? Again, to revisit the question, we are trying to sum e to the power of x when x is 2. And we are trying to sum the first 5 terms of this expression. So I is going to vary from 0, 1, 2, 3, 4.
So would you start with like a for I equals 1 colon 5?
Okay, let me type what you were saying. So for I equals to not 1 because it is starting from 0, right? So it's from 0 to 4 if we are just trying out the 4 terms. So 0 to 4, what should be the next step? Also, a good practice for is to write out the end straight away. Otherwise, we might miss the end later on if you have nested loop. Okay, so what is the next line?
Then it'd be like, say y equals x raised to the I over I factorial.
Okay, so y equals x to the power of I divided by factorial of I. Good. Let's, instead of y, let's call this sum, just because it's easier to understand what we are doing. So let's suppress the output from each run. Anything else in this?
X equals 2.
X is equal to 2, that should be outside, right? Because we can use the same value of x throughout. Anything else? Okay, so first thing first, this is not entirely accurate, so there should be some corrections, but let's see what we get by running this code. And the logic that you guys approached it with is fine. So you basically have to do this calculation in each step, but it still has some loopholes. So let's see what that is. So if I save this, and let's have the answer as sum. So we run this, we get this as the answer. Now, you guys definitely have calculators handy. Can you tell me what the answer should be? Exponential to the power of 2. Or we can as easily do it here. X2 is not 0.6667, it is this 7.3891. So this code did not work. How can we change this?
That one just gave you the last, like just for when I was 4, but when you have to add them all together.
So what do you propose we need to do? You're right. So it just gave you the last output.
So you'd have to do like y equals, or, oh, you just do sum of, would it be sum of I?
Some, I think.
Yeah.
You mean sum of I, like this, or something else?
Wait.
Well,
No,
I
I
mean,
think,
like outside of it, right?
yeah, I don't think it's sum of I. It's just sum of that whole function, isn't it?
Yeah. So basically, you are trying to add this particular term that you are calculating from each run, but you are trying to add them to the previous run's outputs as well, right? That's the logic. The way we would do this is something. Yeah. Any suggestion?
So, but we have to do like another for statement.
You might try it out. I did not try out another nested for loop. It would get even more crazy. So I have a beautiful solution for you guys here. So let's think about the sum that you are trying to get. And before we go into the for loop, let's assume that sum is 0. Okay. Now let's reframe that line as sum equals sum plus this term. So what goes on now? So in the first run, sum is being inputted from the outside value, which is 0. So 0 plus that first term. So sum gets updated to that first term. Now in the second run, when we come to this line, this sum is the update from the last run, which has this x to the power of 0 over 0 factorial. But now, because of this arrangement, it gets incremented by this second term, which is x to the power of 1 over 1 factorial. And like this, because this sum is being redefined in each run, you will get the final output to be this. Make sense? So let's run this and see if we indeed get this. So if I run this, we get a number which is very close. That the reason being we are just trying out 5 terms. The accuracy would increase if we try out more terms. So let's try out 40 terms instead of or 39 terms instead of 5 terms. And if I run this, we get the number which is very close to what is the actual number, exponential 2. So that's another thing that we need to know, that more terms you take in this kind of series expansions, more accurate would be your final answer. But does this step make sense? You are updating the value of the sum in each step, and you start out with a 0 for the sum value, which gets revised in each incremental step. Make sense? So if I type out what we just did, so since we are trying to evaluate exponential 2, that's why we need the x, and this is the initial value of sum that would be updated through the for loop. Now we can try to add one more nuance to this code. So let this be n, the number of terms you are going to include in the series expansion, and let n be input, enter how many terms you need in the series expansion. And actually, since the series starts from 0, if it starts from 0 and if we need n terms, this final value should actually be n minus 1, right? For example, for the 5 terms, that value of n was 4 because it starts from 0. So 0 to n minus 1. And if I save this now, and if I run this, if I need 5 terms in the expansion, the answer comes out as 7. But if I run this again, and if I type we need 100 terms in the expansion, the answer comes out to be the accurate number. So more terms you take in the series expansion, the more accurate your final answer is going to be. So this is number of terms to be counted, to be summed in the series expansion. And of course, to get the most accurate number, this summation should go on till infinity. But of course, you cannot do that. So you just try out a higher number to get the correct final answer. Any question on this one? Okay, so oh, by the way, so this kind of series is called a Telus series expansion, and it is named after this guy, Brooke Taylor, who developed this in 1715. Of course, he had no idea what MATLAB is. Anyways, so here I have some the screenshot from a similar work. Okay, so what I have done over here is in the code is this. So I have also tried to calculate what is the actual value of exponential 2, and then I've tried to compute the difference between the exponential 2 from the actual exponential function minus the sum that we're calculating over here. So of course, if we try out a higher number for n, this difference is going to be very close to 0. But if we try out a very low, smaller number for n, then this sum is not very accurate, and you'd have a larger difference between the exponential x and this sum. So let's try that out here. So diff is absolute x. So I use the absolute because I don't need the sign on the difference. It can be a positive number or a negative number. I just need the difference between the two, and sum. So if I try, okay, let's save this again, and let's try n to be 6. So the difference is 0.1224, which is not that bad, but it is not great either. But if I type, say, n is 18, you can see that the difference is already decreasing by a lot. It is very close to 0. So this tells you how accurate your code is with respect to the actual function. Any question on this one? Okay, so let's go to the next example. So it says generate an array of 10 random numbers between 1 and 100 and get the count of random numbers that are between 1 to 25, 25 to 50, 50 to 75, 75 to 100. So the first thing is to figure out how to generate an array of 10 random numbers between 1 and 100. So the way we do this is this. So rand 10, comma 1 multiplied 100. So this particular syntax generates 10 random numbers which are between 1 and 100. If instead we are trying to generate random numbers between 1 and 50 and just 5 random numbers at that, so I change the number of random numbers to 5 here, and if we are trying to get numbers less than 50, we do this. So remember this particular trick, it might come in handy for the exam next week. So the way you generate random set of numbers. So this number controls the values, and this number controls how many of such random numbers. Okay, so generate an array of 10 random numbers between 1 and 100. So let's try to write the script file. So the way to generate 10 random numbers between 1 and 100 is this. So let's n be rand to 100. Now let's come to the other part of the question. Get the count of the random numbers that are between 1 to 25, 25 to 50, 50 to 75, 75 to 100. So would you try to solve this problem using for loop or if?
Maybe if.
Yeah.
If, because although we are trying to cover for loop, but I think we are done with the details of the for loop. I wanted to show you an example where basically you now know two kinds of logical structures, and you need to decide which one is the best suited for this one. So yes, if, because here we are dealing with some conditions, so we have to do if. So let's try and approach this problem. So if n is between 1 and 100, okay, so let's try out greater than 1 and n is less than 25. Okay, so if this is this, then we have to count this. So let that be n1 to 25, and we are trying to use a similar kind of setup in the previous problem, but now with the if statement. So let this number count the number of these integers that are between 1 and 25. So if we introduce this outside of the loop, so n1 to 25 is 0. And then if we type this out like this, n1 to 25 plus 1, that means every time these conditions are true, this n1 to 25 is going to be updated. Okay? Let's now do something like this. Else if the second condition is n greater than 25 and n less than equal to 50, and then let that new parameter be n25 to 50, n25 to 50 plus 1. Let's suppress the output from each intermediate step. The third condition is else if n is greater than 50 and n is less than equal to 75, then n50 to 75 is n50 to 75 plus 1. And then else. So for the last condition in the if structure, we don't need the condition because it is evidently the only remaining case that is left. N75 to 100, 200 is N75 to 100 plus 1, and then end. Now, just like we introduced this n1 to 25 outside, we need these parameters as well to be introduced before we encounter the loop. N50 to 75 is also starting with an initial value of 0. And N75 to 100 is also starting with an initial value of 0. Okay, so let's save this. This is still not done. It needs a lot of other work as well, but let's save this. So fall 2020 lect 6 code 4. So if I try to run this straight away, I do get an error. Now we have to debug the code. Can anyone suggest what are the sources of error? So what is n over here? If I just type out n is this number. But can you check all these different n's in one single line? You cannot. So for example, you can possibly use those conditions on some one single element of n, say n5. It can then be placed into these conditions and then figured out which one is true. But as such, n as a whole won't work. So we need to have something like ni, where we are trying to extract a single element from that n that we have introduced. So revise your code with ni instead of n. Okay, so let's save this and let's try to run it again. So again, we see an error. Why is this error? Does MATLAB know over here what I is? It doesn't. So you need to figure out what I should be. So therein is the beauty of this code. You need a combination of for loops and I loops, and if loops. So I can be controlled. I is a single variable that is being changed, and you want n1, n2, n3, n4 like this to be compared in all these conditions. So for I equals 1, 2, and we generated how many numbers? 10 numbers. So for I is equal to 1 to 10, and then for this for, we need another end at the end. And then if we save this and run this, we don't get an error. And then if we type out, say, n1 to 25, we do get a number for this, which if you look at what the n number set was, so from 1 to 25, there were how many numbers? So this is 1 to 25, this is 1 to 25. So just two numbers. So that is the output that you get. Okay, so this is the beauty of coding. You can use different logical structures assembled into the same code based on the logic that you are trying to introduce into the algorithm. So I have a screenshot of this. So I showed the possible errors, how to debug that, and then I think this is the corrected code. Any question on this one? So make sure that you understand this specifically for the test next week. And if you don't, just shoot me an email. Okay, so the last thing that I want to do over here is something called histogram. So what histogram does is this. So let's try this out. So histogram n, comma 4. And if I save this, and if I run this again, you will see that a second window would show up. If I can drag my sub window here. So a window would show up that is like this. You guys can hear me, right? Okay. Yeah, I muted myself for a moment. So histogram is, it plots how many numbers are there in each of these different ranges. Okay. So I might ask you to like get a similar kind of plot on the test as well. And there you take screenshot of the code and the plot and put that into the doc file. Okay, so I have a similar example here in the lecture. Go through these examples as well. They're entirely worked out. So it's similar to setting up an array. Also, you can use the break command to come out of a loop at any point. So suppose you don't want to go to the last run and you want to break at an intermediate step. So for this example, find the first number greater than 9 in a random series. So the random series is created by this first line, just like this particular example. And the moment that random number is greater than 9, then I'm saying store that random number in some n required and then break. So this break means control goes out of the loops entirely, and we are left with whatever that greater than n9 number was in the output. So make sure that you understand this and try to run out this code on your MATLAB. Okay, so quick comments about the test. So it is going to be online. You can use your computer, and I'm going to send you the test booklet by 10:50 a.m. next Tuesday. And you have time till 12 noon to upload the work. So there will be a D2L Dropbox for the midterm exam. So upload your work, and as I am asking you guys to upload the homeworks as well in the very same format, take screenshots of all your work from all the examples, all the questions, and paste them in one single doc file, and upload the doc file and upload the separate .m files as well. And I'll be available on the Zoom, so we can set up a Zoom call and you guys can take the test. And this is the homework that's from this lecture. You need to know this homework for the test as well, although this homework won't be due before the test. So the homeworks, this is homework 6. So homework 4 and 5 would be due the day before the test on 14th September, and this would be due on the following week. But make sure that you know how to solve this homework assignment while you prepare for the test. Any questions? Okay, good luck. And if you have any questions in the meanwhile, just let me know and try to make use of the lab time to figure out any doubts that you might have. Thank you. Bye.
You said the test was on the 15th, right?
Test is on the 15th, next Tuesday.
All right, thank you.